Welcome viewers, in this video we will see the details about complete incident matrix. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, complete incident matrix available in the network topology. The given network may be represented in a matrix format in order to go for a simplified understanding. Now we'll see what is the incident matrix, complete incident matrix, and what is the procedure to form the complete incident matrix. Incident matrix gives us the information about the branches which are joined to the nodes and the orientation of the branch, which may be towards a node or away from the node. So it will give the information about nodes and branches, whether the branches are connected towards the node or away from the node. The node of the graph form the rows, branches form the column. So in this matrix, the column is decided by the branches, row is decided by the number of nodes. Right. In that I will see first one, if the branch is not connected to the node, the corresponding element in the matrix is given as the value 0. If the node is not connected, particular branch is not connected, mean we have to mark it as 0. Now we will see the remaining. If a branch is joined, it has two possible orientation. If it is not joined, 0. If it is joined, two things are available. If the orientation is away from the node, the corresponding matrix element is written as +1. Right? If it is away from the node, mean +1. If it is towards the node, the corresponding matrix element is written as -1. Right? Towards the node means -1, away from the node means +1. Right? Now we'll see some important properties of the incident matrix. Each column has only two non-zero elements and all other elements are 0. So in a matrix, in every column, there are two non-zero elements. Non-zero means maybe +1 or -1. All other elements are 0. And one important property is the sum of values of matrix of any column is equal to 0. If you add the elements in the column, any column, it is 0. That is the important property of the incident matrix. So each and every column, if you add all the elements, it will give the value as 0. Right. If a graph have b number of branches and n number of nodes, the complete incident matrix of the order n into b. Right. N is the number of node, b is the number of branches. So branches will decide the column and number of rows decided by the nodes. So that it is node into branch, n into b. Now we'll see the one example problem, how to frame the complete incident matrix. So in this example, obtain the complete incident matrix for the graph shown below. So this is the oriented graph. Oriented graph means the graph will be represented by the line and directions are available. Normal graph means only lines are there. Oriented graph means the directions also given. So this is called a oriented graph. This red color numbers 1, 2, 3 are the nodes. Node is nothing but the elements are connected together. If it is only two elements are connected, simple node. More than two means principal node. So these are all the principal nodes. More than two elements are connected. So 1, 2, 3 are the three nodes. These branches 1, 2, 3, 4. This green color is the branches. So this number of node 1, 2, 3 will decide the number of row. 3 rows are there. 1, 2, 3, 4. 4 branches will decide the number of column. 4 columns. So 3 rows and 4 columns. Now we'll go to the matrix, how to frame the matrix. First we'll have the one tabular column. In the vertical we have nodes 1, 2, 3. Here we have branches 1, 2, 3, 4. Now we'll check each and every node with the branches. First we'll consider the node 1. Here branch 1 is going away. So it is 1. Going away means 1. There is no connection between node 1 and branch 2. So 0. Then node 1 and branch 3 also going away. So plus 1. Node 1 and branch 4 coming inside. Coming inside means minus 1. Right? So node 1, branch 1 going away, plus 1. Node 1 and branch 2 there is no connection, 0. Node 1 branch 3 going away, plus 1. Node 1 and branch 4 coming inside, minus 1. Now we'll go to the second node. Second node and first branch no connection, not connected, so 0. Second node and second branch going away, so plus 1. Second node and third coming inside, so minus 1. Second node and fourth branch going away, so plus 1. Right. Now we'll go to the third branch. Third node and first branch coming inside, so minus 1. Third node and second branch also coming inside, so minus 1. So there is no connection between third node with branch 3 and branch 4. There is no not connected. Not connected means 0. So this can be written in a matrix format. The complete incident matrix is represented as A suffix A. So this can be written 1, 0, 1 minus 1, 0, 1, minus 1, 1, minus 1, minus 1, 0, 0. Having 3 rows because of 3 nodes. 4 columns because of 4 branches. So this is a complete incident matrix. So it will give the details about the branches, whether it is going inside or outside, whether it is connected or not connected. That information can be gathered from this complete incident matrix. So in this video we discuss what is meant by complete incident matrix, what are the properties, and also we solved one example problem. The important property of the complete incident matrix is if we add the column, each and every column elements, it will give 0. Sum of each and every column elements are 0. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.